All right, y'all. So today we're going to talk about the mole. Um, you're going to see me throughout this video refer to a couple different things. When I say mole or moles, or the abbreviation, which is MOL lowercase, that doesn't mean molecule, that means mole. The same way we would say grams or gram or G. Same thing for moles. I'll most commonly use the abbreviation because I'm a little bit lazy. So what is a mole? A mole more specifically is an amount, much like dozen means 12, a pair means 2, a mole means 6, 0, 2, 0, 0, 0, 0, 0, 0. So I got to count these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So 6 with 23 places after it, or much easier, 6.02 times 10 to the 23rd power. So that is a mole. It doesn't matter what you're counting. Like a dozen could mean a dozen eggs, a dozen pants, a dozen magnets, a dozen elephants. A mole can mean 6.02 times 10 to the 23rd pennies, grains of sand, computer monitors, or much more commonly, atoms or molecules. It's used for measuring things that are so small that the only quantifiable way to measure them is in such a large number. So I'll just generally say particles, because like particles can pretty much mean anything. Another name for this is Avogadro's number, because that's the name of the scientist who discovered the mole, Lorenzo something something Avogadro. But yeah, we'll just call it Avogadro's number, or more commonly, the mole. All right, so why does this even matter? Well, for two reasons. First, we just can say that 1 mole is equal to 6.02 times 10 to the 23rd particles. And I'm just going to keep this right here. So we're going to keep this and just keep that in our mind as we move on to the next section, where we look at what's known as a molar quantity. Quantity or molar mass. Now, basically what this means is 1 mole of any element is equal to the atomic mass of that element. So one example, if we look at the element, I got to pick one that I actually know off the top of my head. If we look at nitrogen, 1 mole of nitrogen is equal to 14.01 grams of nitrogen. And so this would actually be the atomic mass in grams of that element. So 1 mole of nitrogen is equal to 14.01 grams of nitrogen. You might be saying, well, where do we get this number from? If we take a look at nitrogen's box on the periodic table, we have an N, we have a 7, and we have the name, nitrogen, and then we have the atomic mass, which is 14.01 AMU, atomic mass units. That's the mass when we measure the protons and the neutrons, add them up, and then take an average based on how common each individual isotope is. Long story short, all we do is we just take that number and we drag it right over here, turn it into grams, and that is how much 1 mole weighs. This is super important. So I'm going to actually now bring this right back up here, and we'll bring it right up here in this area. So I can say 1 mole of element is equal to atomic mass of element. All right. So I'm going to take a brief pause now that we're at this point to point out these things that I have highlighted in green or boxed. Something that you may remember from forever ago is these are what's known as conversion factors. Yes, we are back into dimensional analysis, and we're going to use these conversion factors. We're going to actually start over with this one right here, and then we'll move on over to this one right here, start from the easier one to the harder one. So I'm going to scooch on down, and we're going to do some examples. Examples of mole conversions. All right, so the first one we'll just say if we have 2 moles of nitrogen, how many grams of nitrogen? Well, we're going to start with our dimensional analysis, which if you remember what it was, we start with what we have, 2 mole nitrogen. We set up some big parentheses. We take our units, drop them like it's hot. So we got mole of nitrogen on the bottom. And now we got to use our conversion factor, which is this guy right here. So our conversion factor says that we have moles of nitrogen versus grams of nitrogen. And our numbers are 14.01 for grams and 1 for mole. 1 and 14.01. Mole cancels with mole. And we just get our final answer of 28.02 grams of nitrogen. So that means if I have a sample of nitrogen that contains 2 moles of particles, it is going to weigh 28.2 grams. So it's kind of like saying if you had 2 dozen eggs, you would have 24 eggs. It's almost the same relationship. It's just now we are using math. If I said each egg weighs 1 ounce and we have 2 dozen eggs, then we know we have 24 ounces of eggs. It's almost exactly the same. So we're going to try this now the backwards way. If I have 50 grams of nitrogen, I'm going to need a calculator for this one, and I want to find out how many mole of nitrogen. So once again, we're actually going to start out the exact same way. As we start with 50 grams of nitrogen, we're going to just go ahead and rewrite that. 50 grams nitrogen, make some big parentheses, and drop our units like it's hot. Grams of nitrogen on the bottom. And it's going to be the inverse of the parenthesis up top. So before grams was on the top, now grams is on the bottom. Mole was on the bottom, now it's on the top. And again, those numbers go with those units, 14.01 and 1. So all we have to do is cross out our units and then take 50 divided by 14.01. 50. Sorry, I'm doing this on my calculator now. And that is 3.57 approximately, 3.57 moles of nitrogen. Now, this is really helpful in science because when we're doing chemical reactions, we need to make sure that each individual atom of maybe sodium bonds with each atom of chlorine to make our NaCl. And so when we do that, we need to make sure that we're using the same amount. The problem is because each atom of sodium weighs 22.99 and each atom of chlorine weighs 35.45, we can't just do 10 grams of sodium with 10 grams of chlorine. That's different amounts. So moles help us quantify that. They help us even that out. Instead, we want, if we're doing one individual mole, if we're doing 1 mole of each, then I know I need to measure out 22.99 grams of sodium and 35.45 grams of sodium to get our sodium chloride, which will just be about 58.44 grams. And that's, once again, 1 mole of sodium chloride. So that's why this is important. We need moles to relate things. All right. So like I said, we're going to start with number 1, this type of conversion, and we're going to go to number 2, this type of conversion. So what if I want to know something a little more specific? Let's go ahead and change that up. So let's say I have 2 moles of copper, and I want to know how many atoms of copper I had in the sample. Well, I'm just going to start again with what I start with. 2 mole Cu, make some big parentheses, and drop my units like it's hot. Mole Cu. And now I'm going to go up here and use this thing where 1 mole is equal to 6.02 times 10 to the 23rd particles. Now, particles can be anything. So this time I'm talking about atoms. So 1 mole of Cu equals 6.02 times 10 to the 23rd atoms. Cu. Mole cancels with mole. And I got my answer to be 1.204 times 10 to the 24th atoms of copper. That's pretty easy for me to work with. We have this times 10 to the 24th, but my advice for when you're doing any sort of math like this is just take the numbers, so the 2 and the 6.02, and multiply them first. That's kind of how I did this so fast. 2 times 6.02 is just equal to 12.04. And then just tack on the times 10 to the 23rd after, kind of like an afterthought. The only difference is right here in this end step, I move that decimal up 1 and move this to a 4 instead of a 3. So that's how we do that. All right, so the next one is the opposite. We're going to go backwards. So if I have 57 point, no. If I had 5.7 times 10 to the 25th atoms of copper, how many moles do I have? Well, I'm going to make this easier on me, so I'm going to call that 570, 570 times 10 to the 23rd atoms, Cu. So what I did there, just so I don't lose anyone, is I moved the decimal 1, 2 spaces over, and then drop that down to a 3, because if I move 2 spaces over, then I got to drop that down 2 numbers, so 1 from 25 to 23. And I'm going to go ahead and use my conversion, 6.02 times 10 to the 23rd atoms Cu. You'll notice the unit was dropped like it's hot, and 1 mole on the top. And one of the beauties about these problems is nobody likes dealing with exponents. So while atoms and atoms cancel out, 10 to the 23rd also cancels out with 10 to the 23rd. So my math here really just becomes 570 divided by 6.02. I can do that pretty quick on my calculator, not that quick, but I get 94.7 moles Cu. All right. So with that dimensional analysis, I know not many people like it and they've probably fallen asleep by now. So I'm going to go ahead and show you one more thing. It's the little shortcut we've created so that you can do any dimensional analysis problem pretty easy. Well, sorry, my bad there. It's not a camera. It's already in our photo library. It is this. So what I have right here is what I like to call the mole island, and I'm going to crop it just so it's a little more manageable to deal with. And what this mole island does is it allows you to go from any unit, grams, moles, or particles, to any other unit. All you have to do is follow the arrow. And so I'm actually going to go ahead and demonstrate its usage. Let me just copy that real quick so that I can access it later. And we'll do a new one. If I start with 1,300 grams of carbon, I want to go to some amount of mole of carbon. Well, let's see what I'm starting with. I'm starting with grams. I'm going to moles. So I'm going to come up here. Looks like I'm starting with grams. And I'm going to take this path to moles. That's the bottom green box. So what this is telling me is that I got to use this parentheses on the bottom. And this parentheses says, take what I'm starting with, and multiply it. Let's see. So let's try this out. 1,300 grams carbon, multiply it by that, 1 mole, and A is just a stand-in for whatever we're using. And the atomic mass of A, that's 12.01 grams carbon. And look at that, my units will cancel out. And now all I have to do is 1,300 divided by 12.01. And that's going to be, oh, whoops. I did it wrong because my calculator does not like pressing the decimal function. That is 108.2 mole carbon. So all you have to do is follow this mole island and it'll take you anywhere you want to go. We can even do something a bit harder. All right, so this is going to be the last one and the hardest one, and hopefully it shows you kind of how to use it. So I'm going to start with this, and I'm going to move it right here, just so we still have it. I'm going to go from 7.0 times 10 to the 23rd molecules of H2O. Now that's water. And I want to figure out how many grams of H2O that is. So we haven't done a particles to grams yet, or nor a grams to particles. But by looking at our chart, if we're starting with molecules, all we have to do is go down to moles and then up to grams, and we get it. And so it's 2 steps. We cannot go right from particles to grams. So there is no step for that. But while this may seem daunting, if we follow our instructions, if we follow this mole island diagram, we can make it. So I'm starting with what I have, molecule H2O. And I'm taking this bottom arrow. I see I have 1 mole on the top and 6.022 or 6.02 times 10 to the 23rd on the bottom. 1 mole H2O divided by 6.02 times 10 to the 23rd molecule of water. I'm trying to write that real small. Then I'm taking the upper arrow, and the upper arrow says the atomic mass on top and 1 mole on the bottom. So 1 mole H2O and the atomic mass in grams of H2O. This one's a little tricky. For those that don't yet understand how this works, the atomic mass of H2O is an H, and an O. That's what the H2 means. And the O. So each H is 1.008, 1.008, and the oxygen is 16. So we're just going to add these up. That's going to be about 18. I'm not really going to do the small numbers. So I'm just going to throw 18 in for my atomic mass. And what we get to do is molecule of H2O cancels the molecule of H2O. Times 10 to the 23rd cancels the times 10 to the 23rd. Mole of H2O cancels the mole of H2O. And all that's remaining is 7.0 divided by 6.02 times 18. And that's going to give me something with grams of H2O. So I'm going to do this real quick on my calculator. 7 divided by 6.02 times 18. And that's about 21. That's about 21 grams of H2O. So when you do these problems, my main suggestion is try and follow this mole island diagram. It is in your Schoology, but just in case you're not someone in my class, not looking at Schoology, I'll post it right here and I'll leave it long enough that you can take a screenshot. Anyways, I hope this helped and have a good day.